Indices is actually one of the chapters that is very easy once you start to recognize the patterns. So let's go through them today. Let's go through the rules of indices. Rule 1 is when we can add the powers, right? So we can only add the powers when there is a multiplication sign. So here we can see that when you multiply, you get a to the power of m plus n. So let's look at the example. 2x to the power of 4 times 3x to the power of minus 2 gives us 6x. Because 2 times 3, you get 6x to the power of 4 minus 2. That gives us 6x to the power of 2. Now let's look at rule 2, where the multiplication sign is replaced by the division sign. We can see that the addition sign is replaced by the minus sign, right? So now let's look at the example. So 25x to the power of 4 divided by 5x to the power of negative 2. So 25 divided by 5 gives us 5x, and the power is 4 minus, and then bracket negative 2. So that gives us 5x to the power of 4 plus 2, which gives us 6. Now, let's look at rule 3, where if you have a to the power of m inside a bracket and outside a bracket is to the power of n, you have to multiply the indices, right? So let's look at the example as well. But now the example, we have to use rule 4 as well. So let's look at rule 4. When AB is inside the bracket and the power is outside, the power applies to both A and B. So now let's look at the example. We have 2x to the power of 2, y to the power of 3, and the whole thing is inside a bracket, n to the power of 2. So we first have to do a 2 to the power of 2, right? And x squared to the power of 2 and y cubed to the power of 2. So 2 squared gives us 4. 2 times 2 gives us x to the power of 4. And 2 times 3 gives us y to the power of 6. So that's how you combine rule 3 and 4. Now let's look at rule 5. Anything to the power of 0 gives us 1. So with that, now let's look at the example. We have 2y x to the power of 0. So this whole thing becomes 1. So that just leaves us with 2y times 3y squared. So now let's simplify this, and 2 times 3 gives us 6y. Y to the power of 1 plus 2 gives us y to the power of 3. We can see that a to the power of negative n gives us 1 over a to the power of n. So this shows us that any number which has an indices that is in the negatives can be represented as a fraction. So let's see how to use that in the example given. We can see here that 1 over 2x to the power of negative 2. So since this is a negative indices, let's try and flip that into a positive. So that gives us 2x to the power of 2 times 4 over x to the power of 3. Alright, so let's see how we can simplify this further. So 2 times 4 gives us 6x to the power of 2 over x to the power of 3. So since we are dividing these, we can 6x 2 minus 3. This gives us 6x to the power of negative 1. Now to prove this as a positive indices, let's make it into a fraction. So 1 over 6x. For rule 7, we can see a over b bracket to the power of negative n. To make the indices positive, you can flip a and b, right? So let's see how we can use that in the example. So x over 4 to the power of negative 3. To make this a positive indices, 4 over x to the power of 3 times x over 2 to the power of 2. So 4 to the power of 3 gives us 64, and x to the power of 3 times x squared, and 2 to the power of 2 gives us 4. Let's now simplify this. 64x squared over 4x cubed. 64 divided by 4 gives us 16, and 2 minus 3 gives us x to the power of negative 1. So let's now represent this in a fraction. So 1 over 16x. Alright, so for rule 8, a to the power of m over n gives us a square root a to the power of m and n here. So now let's see how to revert these three to give us our terms in this form. Okay, so square root a gives us a to the power of, so technically m is 1. So 1 over 2, a to the power of half. Let's do the same with our next one, which gives us a to the power of 2 over 3. And our next one, which gives us a to the power of 1 over 4. So what we can do now is, since these are all being multiplied, we can have plus 2 over 3 plus 1 over 4 to give us a to the power of 17 over 12. Solving equations involving indices. We have to always reduce the numbers to their prime factors and apply indices rules slowly. Let us now look at an example. So 25 to the power of x plus 1 equals 125 to the power of x minus 2. Let us see how we can rewrite this to help us solve the following. Okay, so 25 is 5 square and put a bracket and our x plus 1 on the outside. Same for 125, which is 5 cubed, and our x minus 2 outside the bracket. Let's now multiply both of these. Okay, so 5 to the power of 2x plus 2 gives us this, and 5 to the power of 3x minus 3 times 2, 6. So now we can see that both of these are equal. So 2x plus 2 equals 3x minus 6. And let's just solve this equation. So let's move our x terms to one side and our integers to one side. So minus x, negative x gives us negative 6 minus 2, which is negative 8. So x is 8. So that's how you solve this equation. So that's all for indices. See you in the next one.